Hi, this is Miss Barber. Example, two fishing boats depart a harbor at the same time, one traveling east, the other south. The eastbound boat travels at a speed of 3 miles per hour faster than the southbound boat. After 2 hours, the boats are 30 miles apart. Find the speed of the southbound boat. Boy, that was difficult to say. So let's begin this by drawing a diagram that illustrates the problem. We have a boat going south and a boat going east. In case you forgot, for directions I use never eat sour watermelons. And so we have this distance. We understand that after 2 hours, the boats are 30 miles apart. Now, this is eastbound and this is southbound. We know if we look at this, the eastbound boat travels at a speed 3 miles per hour faster than the southbound boat. So we'll begin with the setup of the uniform distance formula, which is distance equals rate times time. Okay? And let's do for eastbound, we have a rate that we'll just call RE, and the time travels 2 hours. For the southbound, we'll call that rate south, and time is also just 2 hours. We see that the eastbound travels 3 miles per hour faster than the southbound. So we know that the distance that the eastbound boat travels is going to be the rate of the eastbound boat times the time, which ends up being the rate of the southbound boat plus 3 times the time of 2 hours, and the distance of the southbound boat is the rate going south times the time, so RS2. Now we'll use the Pythagorean theorem. That's hard to spell, okay? And that's the one that says if you have a right angle, then the sum of the two sides squared is the distance of the hypotenuse squared. So in this drawing, we'll have distance by the southbound squared added to the distance of the eastbound squared is the hypotenuse of 30 miles squared. The distance using the uniform distance formula is going to be the time, which is 2, and the rate of the southbound is just RS, and that's squared, plus the distance E is going to be the RS plus 3 times 2 squared. And let's just go ahead and square the 30, so that'll be 900. Let's do term by term squaring. So you get 2 squared is 4, and the variable RS squared. Let's move the constant on the second term, so 2 squared is 4. And reminder, this is RS plus 3 times RS plus 3, and that's still equal to 900. Let's continue. We'll start with the 4 RS squared plus 4 times RS plus 3. RS plus 3 equals 900. 4 RS squared plus, multiply the two binomials. First terms together is RS squared. Then you're going to plus 3 times RS on the inside and RS times 3 on the outside. So that will be 6 RS plus 3 times 3 is 9. That's equal to 900. Let's continue. 4 RS squared plus, now distribute the 4 to each of the 3 terms of the quadratic. So you got 4 RS squared. 4 times 6 is 24 RS. plus 4 times 9 is 36, and that is still equal to 900. Let's combine some terms. So on the left-hand side, we can combine the two 4RS's. So we have 8RS squared plus 24RS plus, and let's set that equal to 0. So 36 minus 900 is negative 864. That's equal to 0. 8 is common to each of the three terms on the left-hand side. We can factor out the 8. Factor out the 8. Then the first term is just RS squared. 24 divided by 8 is 3. Rate going south. And 864 divided by 8 is 108. And that's equal to 0. Let's factor. So now we will have RS plus something times RS minus something. The factors of 108, that gives us a sum of 3, is plus 12 and minus 9. Let's set each of the terms equal to 0. The 8 is a constant, and that's irrelevant because 8 never equals 0. Solving RS plus 12 equals 0 tells us that rate going south is negative 12, and RS minus 9 equals 0 tells us that rate going south is equal to 9. We are looking for the rate of the boat, and we need this to be positive because that's how we defined it. So the rate of the southbound B-O-U-N-D boat is 9 miles per hour.